So 6-2, it says independent and dependent. We kind of talked about what an independent and dependent is. So look at this first example. The two number cubes, one red and one blue, are rolled. What is the probability that the outcome of the red number cube is even and the outcome of the blue number cube is 5? So think about, what's the probability of the red number cube is even? We have, on a number cube, we have 1 through 6. 1, 2, 3, 4, 5, 6. What of those numbers are even? Our options are 1, 2, 3, 4, 5, and 6. Our options, what are our even?
2, 4, 6.
2, 4, 6. So the probability of that is 3 out of 6, or what can I reduce that to? 1/2. We need to reduce our fractions, guys. We need to reduce the probability as best we can. Okay? So the probability of a number cube is 5. So again, we have our options 1, 2, 3, 4, 5, and 6. What's the probability? It's 5. 1. So 1 out of 6. So it tells us at the top that probability of two independent events can be found by multiplying the probability together. So now I'm going to multiply 1/2 times 1/6. And what do I get? 1 times 1 is 1. 2 times 6 is 12. So the probability of getting an even and a 5 on the blue cube is 1/12. Okay? Are you with me there? Do you see where we came across that? Okay? So if they're independent events, you can multiply, you just multiply them together. Okay? If two events A and B are dependent, then the probability of both events occurring is the product of the probability A and the probability of product B after it occurs. So sometimes that can change. So, the example that Mr. Brooks used a while ago was ace of spades. Well, the probability of getting an ace of spades on the first one is 1 out of 52, right? Okay? Okay. And then the probability of getting an ace of spades on the second one is 0 out of 52, okay? So let's look at this first example. Read example 2 for me.
There are 6 black socks and 4 white socks in a drawer. If one sock is taken out without looking, and then a second is taken out, what is the probability that they both will be?
Okay, so let's look at the first one. What's the probability the first sock is black? There's 6 out of how many total? 10. Okay, 6 out of 10, which reduce. Always, this makes it simpler when you multiply too if you'll reduce. So 3/5. Okay, if I take a sock out and do not replace it, how many socks do I have left? No. 9. I have 9. So if one sock is taken out and not without looking, and then the second is taken out, what is the problem? So we're 9 out of 9 socks. If we took a black one the first time, how many are left? 5 out of 9, because there's 6 total, right? So we're looking at probability of 2 black socks. We're saying 3/5 times 5/9. Okay, what do we know about fractions? We know that I can cross reduce when multiplying. So 5 and 5 could reduce to 1. Make my multiplication a little bit easier, right? 3 times 1 is 3. 1 times 9 is 9. I could have actually cross reduced here too and got 1/3. Yeah, it is a little bit. Okay. So a card is drawn from a deck. So there we are. The probability of getting 2 black socks is 1/3. Okay. Because I took away a black sock. So I'd already drawn one out. So there was only 5 black socks left, right? And then there was only 9 total socks because I had 10 socks and I took one away. Okay. So look at the exercise. A card is drawn from a deck of 10 cards numbered 1 through 10 and a number cube is rolled. Determine each probability. Okay. So the probability of a 10 in a deck of cards numbered 1 through 10. What's the probability of a 10? 1 out of 10. Okay. And then times the probability of a 3 on a number cube. What are the options for a number cube? 1, 2, 3, 4, 5, 6. So 1 out of 6. Can I reduce? No. So I'm just going to multiply straight across. 1 times 1 is 1. 10 times 6 is 60. So the probability of a 10 and a 3, 10 in a those deck of cards and a 3 on a number cube is 1/60th. Are we kind of getting the idea?
Yes.
Okay, it's pretty straightforward and simple. What's the probability of this? Multiply it by the probability of that. That's how you're going to get your probability. So probability of 2 even numbers. So the first even number is on the deck of cards. So our options on the deck of cards are 1 through 10, right? 7, 8, 9, and 10. And our options on the number cube are 1, 2, 3, 4, 5, 6. Okay, so what are our even numbers on the... So 2, 4, 6, 8, 10. So there's 1, 2, 3, 4, 5 out of 10, right? Which reduces to 1/2. I'm going to go ahead and put it down here. And then evens. What are my evens? 2, 4, 6 on the number cube. So 3 out of 6, which also reduces to 1/2. Oh, I should put a multiplication sign there, not a equal sign. Okay, because I reduced this one to here and this one to here. Are you with me there? See what I wrote down? So 1 times 1 is 1. 2 times 2 is 4. I would have gotten the same thing on top, but I would have gotten 15/60ths. And then I would have had to reduce that, and that also reduces to 1/4. Okay? I just want to do it as simple as I can for multiplication. Okay, number 3, 2 prime numbers. Okay, so here's where we're going to get a little shady. Prime is a number that is divisible by 1 and itself, okay? So we're not considering 1 prime. So we have 2, 3, 5, 7, and that's it. So 2, 3, 5, 7. So 4 out of 10. I'll reduce it in a minute, okay? And then we have prime numbers on the bottom. 2, 3, 5. So 3 out of 6. So if I reduce 4/10, it would be 2/5 times 1/2. Can I reduce that anymore? Yes. 1, 1. 1 times 1 is 1. 5 times 1 is 5. So the probability of getting 2 prime numbers is 1/5. Pretty simple, right? Okay. Okay. Look at number 4. Probability of 9 in an odd number. So we're still on the first set of data. 9, there's only, what? How many 9s? 1 9. So 1 out of 10 times an odd number. 1, 3, 5 are all odd numbers. That's 3/6. So I'm going to go ahead and reduce that to 1/2. Do you see where I got those numbers? Yes. Okay. Am I going too fast? No. Okay. 1/10 times 1/2 is 1. Very small chance, like a 5% chance. But you're saying there's a chance.
I love that movie.
Okay. Probability of 2 numbers less than 4. Okay. I'm going to go where I can see my numbers. 2 numbers less than 4. So what numbers are less than 4? Does less than, okay, hold on. Does less than 4 include 4? No. If it's less than 4, it does not include. So we would be 3, 2, 1. So that's what? 3 out of 10, okay? And then less than 4 on the second one would be the same. 3, 2, 1. 3 out of 6 reduces to what? 1/2. So 3/10 times 1/2. Can I simplify those anymore? No. 3 times 1 is 10 times 2 is 20th. So 3/20 is about 15% chance. Okay. And probability of 2 numbers greater than 5. So does that include 5? No. Nope. So 6, 7, 8, 9, 10. So 5 out of 10. And greater than 5 would just be 1 out of 6. So I'm going to say 1/2 times 1/6 is 1/12. Okay. So there's where we're at. Okay. Let's finish these last few. Okay. So we're changing modes here. Okay. Now there are 4 red, 6 green, 5 yellow pencils in a jar. Once a pencil is selected and is not replaced, that changes your denominator, guys. Okay. Remember, numerators on top, denominators on bottom. It changes your total outcomes. Okay. Determine each probability. So red, then yellow. So at first we have 15 pencils, right? Okay, so the probability of a red is 4 out of 15. I can't reduce that. Okay, and then times yellow, which is 5 out of how many?
15.
No, 14. Remember, we're not replacing it. So we've got to take that denominator down 1. Okay, if I took a red pen out, I no longer have 15 pen or pencils. I have 14, right?
Oh, so if there's. Oh, okay.
So if it's not replaced, you have to reduce the denominator.
So the second denominator is always going to be 14?
On these, yes. Okay, on other, it's just going to be 1 less. If you take it out and don't replace it, it's 1 less, okay?
Watch the numerator in case they do the same color like twice in a row.
Yes. So if you took if I took it, well, they do it down here, so we'll get to, okay. So here is, I'm going to reduce this. They're both divisible by 5. 5 and 15 are both divisible by 5. So 4 times 1 is 4. 3 times 14 is 42. Ooh, I could have reduced this too. I could have said 2 and 7. So it's 220 first. The only thing, if I don't reduce, it just makes me where I have to reduce at the end. Are you with me there? Okay, so if I don't reduce in the problem, it just makes me reduce at the end, which is fine. Okay, so actually number 8 is what he was kind of talking about just now. Okay, everybody caught up? Okay, so 2 green. So the probability of a green is 4 out of 15. 1 green first, right? Okay, if I take a green out, how many green are left?
13.
How many green are left? 3. How many total? 14. Okay, so now I'm going to sit here and reduce. 3 and 15 are divisible by 3, so 1 and 5. 4 and 14 are divisible by 2, so 2 and 7. So 2 times 1 is 2. 5 times 7 is 35ths. And that does not reduce anymore. So we took 1 away from the top and we took 1 away from the bottom because it stayed the same color. Got that? Yay or nay? Okay?
Yay or nay. Same thing for yellow too.
Yeah, down here. So number 9, green and then yellow. So what's my green? 6. 6 out of how many total? 15. And then yellow would be 5 out of 14. Okay, so we would cross reduce. These are divisible by 5, so 1 and 3. These are divisible by 2, so 3 and 7. 3 times 1 is 3. 4 times 7, 3 times 7 is, and that reduces 1 more time. That's right, yeah. It reduces 1 more time, but I should have been fully reduced when I did it in there.
3 over 3 on one side.
Oh, yeah. Okay, so red and then green. Red is 4 out of 15, and green is 6 out of, nope, we took 1 away, so 14. Okay, so what I want you to do is we're going to go through and finish these, but I'm going to stop the recording right here, okay? So are you with me? So I want you to finish these and we'll talk about them in just a minute.